This video briefly outlines some of the new features in T7.030, including unassigned horizon support and seismic access improvements, and enhancements to the World Toolkit, the Interpretation module, the Model and Map module, and the Horizon Volume utility. The new upgrade features the addition of an unassigned horizon. There can often be many hundreds of well horizon picks in a project where there are only a handful of real seismic horizons. This new feature negates the need for these picks to be assigned to either a T7 primary or marker horizon. As such, there have been changes made to the ASCII well pick import tool in T7, as well as the OpenWorks well data import tool and the Decision Space and Petrel well data export tools, so that it is now possible to associate picks with the unassigned horizon. The Seismic Access Definition Editor has been improved with a facility to scan the seismic volume data for its amplitude range and provide a histogram display from which the colour map range may be set. The user-defined amplitude range corresponds to the red and blue lines in the graphical display, and it is these values that are passed into the access definition if the Apply button is used. As well as this, the access definition can now provide applications with 8, 16 or 32-bit integer values, or 32-bit floating point values, as required, rather than being restricted to 8-bit integer, leading to improvements within the seismic slicer, horizon attribute extraction, horizon volume utility, well seismic extraction, and seismic capture tool applications. To provide a means of quickly and easily making and maintaining well pick assignments, a new well pick assignment tool has been added. It can operate on both well horizon picks and well fault picks. A new ASCII import tool has been added to load zonal attribute data and is available alongside the LAS import tool. It is now possible to import well-paced interval velocity data from which time depth curves can be created or updated. Loaded well data can now be projected onto nearby sections. It is translatable and can be coloured according to attribute data, zonal data, lithology, stratigraphy, or reservoir quality. Concentric sets of arbitrary lines can now be created, enabling the visualization and interpretation of seismic data at specific and increasing distances from a given point of interest. Section-based seismic processing options have been extended to allow the computation and display of complex seismic attributes, including instantaneous amplitude, instantaneous phase, instantaneous frequency, and peak filter. A new style option has been added, enabling well attributes including zonal, horizon, lithology and reservoir quality to be viewed as solid 3D objects encircling the well trajectory. It is now possible to adjust well picks interactively in the volume editor instead of loading the well into the well editor. The T7 display method editor has been simplified and improved. Many of the control buttons have been replaced with icons. The name of the display method is now editable in the top drop-down selection box, and edits are automatically saved. It is now possible to backstrip or vary the displacement defined by the intersection polygons upon fault surfaces. Displacement backstripping in T7 enables the visualization of fault displacement and hence the calculation of fault rock properties over time. Backstripping at successive horizons allows each stage of the fault's development to be visualized and analyzed independently. Displacement can be removed from either the footwall, the hanging wall, or both elements, and can also be flattened to a paleodatum, and the complex relationships at fault intersections can be modelled. Here is the original fault with polygons displayed. The fault is then backstripped and flattened to a paleodatum. This removes displacement from the lower blue horizon to mimic the juxtapositions present in this growth fault at this early stage of development. We then perform fault seal analysis on the original and backstripped faults. first observing ancient juxtapositions in an Allen diagram and then calculating the shale gouge ratio to approximate steel behaviour at this earlier time. Similarly, we can model displacement variation. Displacement variation allows us to mitigate uncertainty via quick sensitivity analysis. The original fault undergoes displacement variation, and in this case we have modelled an increase and decrease of 200 metres, reflected in the new location of the polygons. Once again, fault seal analysis can be performed on the new virtual faults, first observing juxtapositions in an Allen diagram, and then calculating the shale gouge ratio. Standard geometric properties can now be extracted from the basic Z data in Horizon Data Volumes using the updated Horizon Volume utility, including dip, dip azimuth, roughness, and minimum, maximum, mean, Gauss, differential, and magnitude of curvature. The Horizon Volume utility can also be used as a means of extracting seismic data in a vertical window about a horizon or between two horizons. The seismic data is extracted over a vertical window per horizon data point. Therefore, the output value per horizon data point is a statistical measure and may be set to mean amplitude, RMS amplitude, maximum magnitude, or average energy. These are just some of the highlights of the T7.030 upgrade. For a more comprehensive overview of the functionality of the enhancements, please see the release notes available now online. Contact support for more details. This concludes our video on new features in T7.030. Thank you for watching. For more information, please visit badleys.co.uk.